Hello dear students of plus 2 medical and non-medical respected teachers। उम्मीद है तुम सारे खुश होवोगे, चढ़ती कला च होवोगे। आज मैं डिस्कस कर रहे हैं कैपेसिटेंस दा सैकेंड पार्ट। फर्स्ट पार्ट दे विच असीं डेफिनेशन कैपेसिटेंस दी कर चुके हैं, यूनिट्स कर चुके हैं, किसी आइसोलेटेड कंडक्टर दी, स्फेरिकल कंडक्टर दी कैपेसिटेंस दी एक्सप्रेशन ड्राइव कर चुके हैं। पैरेलल प्लेट एयर कैपेसिटर दी कैपेसिटेंस दी एक्सप्रेशन भी ड्राइव कर चुके हैं। सो आज डिस्कस करूंगा हाउ ए कंडक्टर behaves between the plates of a parallel plate capacitor. So behavior of a conductor between the plates of a parallel plate capacitor. Very important. Just try to understand. There are 4 points I will discuss in detail. Suppose P and Q be the two plates of a parallel plate capacitor. Let plate P is positively charged, plate Q is negatively charged. Then there will be electric field from plate P to plate Q. Let E naught be the electric field. Let a conducting medium is placed between the two plates of parallel plate capacitor. Then left side of the conducting medium or conducting slab, you can say, acquires negative charge, and right side acquires positive charge because of induction. As a result, an opposite field is set up. As it is a conductor, so equal and opposite electric field is set up which cancels the applied electric field. So it means inside the conducting medium, applied field is cancelled by the induced field. So it means net field inside the conducting medium is always zero. There will be no electric field within the conducting medium. So E is equal to 0. And this phenomenon is known as electrostatic shielding. So electrostatic shielding means the region within the conductor where there is no electric field. That's why we are safe inside our car during dust storm than to be under a tree. ਅਸੀਂ ਕਾਰ ਜ਼ਿਆਦਾ ਸੇਫ ਹੈ ਦਰਖਤ ਥੱਲੇ ਖੜਨ ਨਾਲੋਂ ਜਦੋਂ ਬਿਜਲੀ ਲਸ਼ਕ ਰਹੀ ਹੋਵੇ, ਸਟਾਰਮ ਆ ਰਿਹਾ ਹੋਵੇ, ਮੀਂਹ ਪੈ ਰਿਹਾ ਹੋਵੇ, ਸੋ ਅਸੀਂ ਕਿੱਥੇ ਸੇਫ ਹੈ? ਸਾਡੀ ਕਾਰ ਦੇ ਵਿੱਚ ਜਾਂ ਸਾਡੇ ਘਰ ਦੇ ਵਿੱਚ। we are safe because we are isolated from the external field. Second point, as E is equal to sigma or epsilon naught, that is electric field depends upon surface charge density and surface charge density depends upon Q. So E is directly proportional to charge. If E is 0 inside the conductor, charge is also 0. So Q is also 0. It means there is no charge within the conducting medium because charge always reside over the surface of the conductor. Charge हमेशा surface से reside करेगा, कंडक्टर के अंदर कोई चार्ज नहीं होएगा. So Q is also 0. Third point, by using Gauss law, we have phi is equal to Q over epsilon naught. If Q is 0, phi is also 0. It means there is no electric flux inside the conductor because there are no electric lines of force. So electric field is 0, charge is 0, flux is also 0 inside the conductor. Very simple. Fourth point, E is equal to minus dV by dx. As E is equal to 0, this is the relation between electric field and potential. So electric field is equal to negative gradient of potential. dV by dx is called gradient of potential. So as E is 0, so dV by dx is 0. ਹੁਣ ਕਿਸੇ ਚੀਜ਼ ਦਾ ਡੈਰੀਵੇਟਿਵ 0 ਹੋਵੇ ਤਾਂ ਕੁਆਂਟੀਟੀ ਕੀ ਹੁੰਦੀ ਹੈ? ਕਾਂਸਟੈਂਟ. So as dV by dx is 0, so therefore V is constant. It means potential inside the conducting medium is constant. In other words, potential difference is 0. there will be no potential difference between 2 points inside the conductor. So these are the 4 points when you are asked how a conducting medium behaves between the parallel plates of a parallel plate capacitor. First point is there is no electric field. This phenomenon is called electrostatic shielding. Second point, there is no charge because charge resides on the surface of the conductor. Third, there is no flux because E is 0, charge is 0. And potential inside the conductor remains constant. These are 4 simple points. So this is how a conducting medium behaves in an external electric field, you can say, because by applying parallel plate capacitor, we have applied external electric field E naught, because plate P is positively charged, Q is negatively charged. Next, now we have derived expression for capacitance of a parallel plate capacitor when a conducting slab is introduced between the plates. We have derived expression for air capacitor, parallel plate air capacitor, when there was no medium within the plates. Now, suppose P and Q with the plates of parallel plate capacitor, sigma is the surface charge density, Q is the magnitude of charge on each plate, and A is the area of cross section of each plate. Let a conducting slab of thickness x, which is less than distance between the plates d. So x is less than d, is placed between the plates of parallel plate capacitor. Then we have proved E is 0 because left side of slab becomes negative, right side becomes positive, equal and opposite electric field is set up which cancels the applied field. So net field inside the connecting slab will be 0. So C naught, capacitance of air capacitor, we have already proved epsilon naught A by D, which depends upon dimensions of the conductor. This is equation number 1. When x is less than d and connecting slab of thickness x is introduced between the plates of parallel plate capacitor, suppose V is the potential difference between the plates. Now V will be equal to E naught into d minus x, because there is no potential difference within the thickness x. So V will be equal to E naught into d minus x, not E naught into d. Or V is equal to E naught means sigma upon epsilon naught, already proved. Or sigma is equal to Q upon epsilon naught A d minus x. So from this equation we have Q upon V, that is C, is equal to epsilon naught A by d minus x. So C is equal to Q upon V is equal to epsilon naught A by d minus x, which is the required expression for the capacitance of a parallel plate capacitor when a conducting slab is introduced between the plates of the capacitor. And x is the thickness of the conducting slab, d is the separation between the plates of the parallel plate capacitor, A is the area of cross section of each plate, and epsilon naught is the permittivity of free space. So you have to remember this expression. Now, if we take d common from this denominator, so we have C is equal to epsilon naught A, take d common, it will be 1 minus x upon d. Now this epsilon naught A by d is nothing but C naught. So we can compare capacitance of this conducting medium capacitor and air capacitor. So C is equal to C naught upon 1 minus x upon d. It proves that as x increases, capacitance of the condenser increases. So more is the thickness of the conducting slab, more is the capacitance. It means we can increase the capacitance of parallel plate capacitor by introducing a conducting slab and increasing the thickness of the conducting slab. And as a special case, when x becomes d, that is a whole space available between the plates is filled with a conducting slab, then x will be equal to d, or 1 minus d is equal to 1 minus 1 is equal to 0. So C becomes infinite. So we can increase capacitance of parallel plate capacitor to any desired value by using a conducting medium between the plates of a parallel plate capacitor. So which is the required expression for capacitance of a parallel plate capacitor when a conducting slab is introduced between the plates of the parallel plate capacitor. Now we have derived expression for energy stored in the capacitor, because when body is charged, any body is charged, work has to be done. So when capacitor is charged, work has to be done. So expression for energy stored in a capacitor. Parallel plate capacitor, we are talking about parallel plate capacitor. So capacitors may be parallel plate capacitor, spherical capacitor or cylindrical capacitor. But in your syllabus, we have discussed only parallel plate capacitors. Suppose V is the potential difference, Q is the charge at any time, C is the capacitance. Then by definition of capacitance, V is equal to Q upon C or C is equal to Q upon V. Now, we have said when a capacitor or conductor is charged, work has to be done. So, suppose dq is the additional amount of charge added to the capacitor. That small amount of work done in order to increase the charge by dq is given by dw is equal to v dq by definition again. Potential difference is also defined as work done per unit charge. So dw is equal to v dq or v is equal to q by c dq. Therefore, total work done in giving the charge from 0 to q is given by w is equal to integral 0 to q by c dq. C is constant, can be taken outside the integration. So therefore 0 to q dq. Simple integration. W will be equal to 1 upon c q square by 2. Integration formula q power 1 plus 1 upon total power q square by 2. Or this work done is stored in the capacitor as its electrostatic potential energy. So electrostatic potential energy stored in a capacitor is given by U is equal to half Q square upon C. This is general expression. U is equal to half Q square by C. This is equation number 1. Another form, if Q is equal to CB, we know Q is equal to CB. We substitute the value of Q here, so it will be half C square V square upon C. 1 C cancels, so it will be half CB square. Or U is equal to half CB square. Question number 2. Another expression in terms of C and V. If you substitute the value of C in the same equation, so it will be U C is equal to U is equal to half QV. Substitute the value of C will be Q upon V, Q cancels, half QV. So we have got 3 expressions for energy stored in a capacitor. U is equal to half Q square by C, U is equal to half CV square, and U is equal to half QV. Another expression as E is equal to sigma upon epsilon naught. Sigma is equal to Q upon A epsilon naught. This implies Q is equal to E naught epsilon naught EA. We have to derive another form of energy stored in terms of electric field. So electric field is given by sigma upon epsilon naught. Sigma is Q upon A, charge upon area. This implies Q comes out to be epsilon naught EA. So substitute the value of Q in this equation and C for air capacitor is given by C naught A upon D. So it will be half epsilon naught square Q square E square A square upon C means epsilon naught A D ऊपर चला जाएगा, एक epsilon naught cancel हो गया, एक A cancel हो गया, so U comes out to be half epsilon naught E square A into D. What is A into D? A into D is area of cross section of the plate into distance between the plates. It means this gives volume of the capacitor. So from this equation we can find energy stored per unit volume. Energy stored per unit volume is called energy density. Energy stored per unit volume is called energy density and is equal to half epsilon naught E square. So energy stored in a capacitor or energy density is directly proportional to square of the electric field between the plates. So this is how energy is stored or expression for energy stored in a capacitor. So this is all about behavior of conducting medium between the plates of parallel plate capacitor, expression for capacitance of a parallel plate capacitor when a conducting slab is introduced in the plates, and expression for energy stored in a capacitor and expression for energy density. So this is the second part. Then stay tuned till third part of the same chapter, capacitance, third part. So बेटा फिर बार बार कह रहे हैं जे घर बैठे वधिया फिजिक्स समझनी चाहते हो, मैं बहुत मेहनत कर रहे हैं और आने वाले समय होर मेहनत करूंगा तो फिजिक्स थोड़े फिंगर टिप्स से हो जाएगी। सो ਵੱਧ ਤੋਂ ਵੱਧ अपने दोस्तों ਨੂੰ शेयर करो, आप सबसक्राइब करो, अपने क्लासमेट्स ਨੂੰ टीचर्स ਨੂੰ भी रिक्वेस्ट कर रहे हैं, ਤੁਹਾਨੂੰ भी बहुत फायदा होएगा। ਤੁਸੀਂ कुछ नहीं करना, सिर्फ एक स्क्रीनशॉट ले सकते हो, ये लेके ਤੁਸੀਂ ਇਹਦੀ ਫੋਟੋ ਪ੍ਰਿੰਟ ਆਊਟ ਲੈ ਕੇ डिस्कस कर स्टडी कर सकते हो, या इतों ਤੁਸੀਂ अपने टीवी ना ऑन करके मैगनीफाई करके आराम ना स्टडी कर सकते हो। तो सिंपलीफाई करना पर्पज ये है कि टाइम बच जाता है, सो पहला लिखना पैंदा है, इस करके नाल लिख के वीडियो बहुत लंबी हो जाती है और मज़ा भी नहीं आता। तो ऑल द बेस्ट, बी हैप्पी, खुश रहो यार। तो इस तरह ही मेरे नाल जुड़े रहो और फिजिक्स तुहानू मैं गारंटी करदा आने 2-3 महीने लगातार जुड़ के पैना तो फिजिक्स थोड़ी फिंगर टिप्स से हो जाएगी। बहुत कुछ करना हाले, बहुत अच्छी अच्छी वीडियोज आनी है, जस्ट मैं हाले इट इज़ द बिगनिंग, बेस्ट इज हाले येट टू कम। तो कहने कहानी अभी बाकी है दोस्तों, तो इस करके बी हैप्पी।